Now, before we go over this problem, let's talk about the difference between DC current and AC current. DC represents direct current, AC is alternating current. So if you graph these two, let's say if you plot voltage versus time or even current versus time, DC current has a constant voltage and therefore constant current. In an AC circuit, the voltage will vary. I need to change the graph and make it look like this. So you have a sinusoidal function. So that's how the voltage varies in the AC circuit, and here is for a DC circuit. Now, a DC current is available if you use a device like a battery. If you connect the battery across a resistor or even a light bulb, current flows in one direction. The conventional current flows from the positive terminal of the battery towards the negative terminal of the battery. Now, let's say if you connect a resistor across a 120 volt source found in the typical household. Now, in this case, the current constantly reverses direction. In one instant it's traveling in this direction, and then in another instant it's traveling in the opposite direction. And so it oscillates 60 times per second. And so the frequency is 60 hertz. It constantly reverses 60 times in one single second. So that's the difference between direct current and alternating current. Now let's go back to this problem. The RMS standard line voltage is 120 volts in a typical household. Calculate the peak voltage. The peak voltage is equal to the square root of 2 multiplied by the RMS voltage. So the RMS voltage is 120 volts. And if we multiply that by the square root of 2, this is going to equal 169.7 volts. You can approximate it and say it's about 170 volts. So that's the peak voltage found in a typical household line. Number 2, consider the sinusoidal function shown below. Calculate the RMS current that's flowing in the circuit. If this graph represents the current flowing in the circuit at any given instant of time. So what is the peak current? The peak current is the maximum current. The maximum current is 10 amps. So if we want to calculate the RMS current, it's going to be the peak current divided by the square root of 2. So it's 10 amps over the square root of 2. And so this is going to equal 7.07 amps. So that's how you can calculate the RMS current from the peak current. Number 3, a 200 watt laptop is connected to a 240 volt AC line. Calculate the RMS current flowing from the outlet. So we have the average power that's consumed by the laptop. It's 200 watts. And the line voltage, that represents the RMS voltage, the root mean square voltage. And so that's 240. So in part A, our goal is to calculate the RMS current. The average power is simply equal to the RMS voltage times the RMS current. And so this is 200 watts. That's going to equal 240 times the missing current value. So the RMS current is going to be 200 watts divided by 240 volts. And so that's equal to 0.8333 amps. Now let's calculate the peak current. The peak current is the square root of 2 times the RMS current. And so it's going to be the square root of 2 times 0.8333. And so this is equal to 1.1785 amps. Now part C, calculate the peak voltage. The peak voltage is going to be the square root of 2 times VRMS. So that's the square root of 2 times 240 volts. And so that's going to be 339.4 volts. Now let's move on to part D. Calculate the maximum power delivered from the AC line. The maximum power is equal to the peak voltage times the peak current. So that's going to be, the peak voltage is 339.4 multiplied by 1.1785. And so the maximum power is 399.98, which you could say it's about 400 watts. Now it's important to understand that the maximum power is twice the value of the average power, which means the average power is 1/2 of the maximum power. So in this case, we could have done 2 times 200 watts, and that would have given us 400 watts, which is the maximum power. So let's talk about some formulas that you need to know. So you need to know that the maximum power is simply the peak voltage times the peak current, and the average power is the RMS voltage times the RMS current. Now let's say if you want to get the maximum power in terms of these values. So let's focus on this equation. Now we know that the peak voltage is the square root of 2 times the RMS voltage, and the peak current is the square root of 2 times the RMS current. Now the square root of 2 times the square root of 2, that's equal to the square root of 4, which is 2. So the maximum power is 2 times the RMS voltage times the RMS current. So those are the two main ways to calculate the maximum power. And as we said before, this is equal to the average power. So the maximum power is twice the value of the average power. Now let's focus on this equation. Now we can get the average power in terms of these values. So VRMS is equal to the peak voltage divided by the square root of 2, and the RMS current is equal to the peak current divided by the square root of 2. So these two together will give us a 2 on the bottom. So therefore we can say that the average power is simply 1/2 of the peak voltage times the peak current. And the peak voltage times the peak current represents the maximum power. So thus we can say that the average power is 1/2 of the maximum power. So make sure you know these formulas, because you can use it in different ways. Number 4. Now this is going to be the last problem of this video. An RMS current of 5 amps flows through a 10 ohm resistor. Calculate the average power absorbed by the resistor. So if we draw a circuit, let's say this is the AC power source, and here we have a 10 ohm resistor. So the current that's oscillating in this circuit, it's really going in both directions, so keep that in mind. The current is 5 amps. So how can we calculate the average power? The average power is the RMS voltage times the RMS current. And based on Ohm's law, V is equal to IR. So the RMS voltage is equal to the RMS current times the resistance. So what I'm going to do is replace the RMS voltage with the RMS current times the resistance. So if we plug that in, this is going to be equal to the current times the resistance times another current value. So the average power is the square of the RMS current multiplied by the resistance. You can also say that it's 1/2 of the square of the peak current times the resistance. But we're not going to use that equation in this example since we already have the RMS current. So the RMS current is 5 amps, and we need to square it, and the resistance is 10 ohms. 5 squared is 25, and 25 times 10 is 250. So the average power absorbed by this resistor is 250 watts. Now let's calculate the peak voltage. So we can use this equation to calculate the RMS voltage. The RMS voltage is the RMS current, which is 5 amps, multiplied by a resistance of 10 ohms. So that's an RMS voltage of 50. Now the peak voltage is the square root of 2 times the RMS voltage. So that's going to be the square root of 2 times 50. And so that comes out to be 70.7 volts. So that's the peak voltage. And that's it for this video. So now you know how to do some calculations involving alternating current.